Hello everyone and welcome to my presentation on the SCRUM methodology for cyber-physical systems or CPS. SCRUM is an agile framework that focuses on iterative and incremental development. It emphasizes collaboration, adaptability, and continuous improvement, which are crucial when developing cyber-physical systems. CPS involves integrating software and physical hardware components, and Scrum's adaptability allows us to manage these evolving requirements effectively. Let's start with an overview of Scrum. Scrum works in iterative sprints, typically lasting between 2 to 4 weeks. These short cycles allow us to continuously evaluate progress and make adjustments, which is very helpful for CPS projects where both hardware and software requirements may change over time. There are three key roles in Scrum: the product owner, the Scrum Master, and the development team. Each plays an important part in making sure the project is managed effectively. Scrum also emphasizes collaboration and feedback. Continuous feedback helps align both software and hardware components, which is vital for CPS. Now let's talk more about these roles. The product owner represents the stakeholders and is responsible for defining the requirements and prioritizing features. In a CPS context, the product owner needs to work closely with both hardware and software teams to ensure all requirements are aligned. The Scrum Master facilitates the Scrum process, removes any obstacles, and makes sure the team follows Scrum principles. For CPS projects, this role is crucial to manage the challenges of hardware-software integration. The development team is a cross-functional group responsible for delivering product increments. For CPS, it's important that these teams include members with expertise in both software and hardware so that they can effectively manage the integration tasks. Scrum has three main artifacts. The product backlog is a prioritized list of features, including both hardware and software requirements, making sure both domains are represented. The sprint backlogs includes tasks selected from the product backlog that will be focused on during the current sprint. For CPS, this often involves balancing hardware prototypes and software features. Finally, the increment is the product outcome at the end of each sprint, which must be tested to ensure both hardware and software components work together harmoniously. Let's move on to the key Scrum events. Sprint planning is where the team decides what features and tasks to complete in the upcoming sprint. For CPS, this includes planning for hardware coordination, such as prototyping and testing. The daily stand-up is a short 15-minute meeting where each team member discusses their progress, challenges, and plans for the day. Hardware integration issues are highlighted here to prevent any delays. A sprint review involves demonstrating the increment to stakeholders and gathering feedback. In CPS, this means showing how hardware and software components are integrated. Finally, in the sprint retrospective, the team reflects on the sprint to identify what went well and what could be improved. For CPS, this includes discussing hardware-software integration and communication issues. Scrum has several strengths for CPS development. First, its adaptability allows the teams to quickly respond to changes, which is important for evolving hardware and software requirements. Quick feedback loops through regular sprint reviews help catch and resolve integration issues early. Finally, incremental progress allows for gradual integration and testing, reducing the risk of large-scale issues. However, Scrum also has some weaknesses when applied to CPS. Without clear goals, the flexibility of Scrum can lead to potential chaos, especially with the complexity of hardware-software coordination. Integration challenges are common, as hardware integration requires detailed planning, which can be difficult to fit into short sprints. There is also a risk of having limited documentation due to Scrum's focus on working software, which can be problematic for complex CPS projects that require detailed integration specifications. To effectively apply Scrum to CPS projects, I have a few recommendations. First, include hardware in the loop testing in each sprint to ensure integration is continuous and any issues are caught early. Make sure to set clear sprint goals that include both hardware and software deliverables. Finally, a strong Scrum Master with expertise in managing software and hardware integration is key to handling cross-domain issues proactively. To give a real-world example, imagine a smart home system that integrates sensors, actuators, and software. In such a project, using Scrum can help manage software updates and hardware integration. One challenge in this scenario is coordinating firmware updates with software features by involving hardware engineers in daily stand-ups and incorporating testing during each sprint. Scrum can be adapted to handle these challenges effectively. To conclude, Scrum can be highly effective for CPS development when adapted properly. This includes incorporating frequent hardware integration and testing, having clear sprint goals, and ensuring strong collaboration between hardware and software teams. It is important to maintain flexibility, collaboration, and continuous improvement throughout the development process, as these are key to success for CPS projects.